That old-timey warrior is trying to sling math away. Never fear. Math Man is here to save the day. Math is at risk. I'm pretty sure that guy is from Sumer, and he's probably thinking in degrees. That's probably his problem. So a sling is being spun at 75 revolutions per minute. The sling is 26 inches long. First question here is we got to find angular velocity in radians per second. So I'm going to start with that 75 revolutions per minute. That's my starting point. And then I can find my conversion factor. So this is rotational speed. I'm asked to find angular speed or velocity, as the case may be. So to get from rotational speed to angular speed, I need this conversion factor, 2 pi radians over 1 rotation, or 2 pi radians over 1 revolution. I'm going to use the word revolution so that my revolutions will match the green revolutions. And then I'm going to throw one more conversion factor on here because the directions ask me to get my final answer in radians per second. And the initial rotational speed is given to me in minutes. So 1 minute, 60 seconds. And then revolutions and revolutions are going to cancel. Minutes and minutes are going to cancel. The units that are left will be radians on the top and seconds on the bottom. So let's go ahead and drop this into the calculator. So I'm going to have 75 times 2. I'm going to leave pi as part of my answer. So I'm not going to put the pi into the calculator. We'll just have to write that down afterwards. And then I'm going to divide that by 60. So I'm going to get 2.5 on the calculator. And then pi is going to be part of this answer, because I did not multiply that pi into the calculation in the calculator. So 2.5 pi radians per second. Part 2, what is the linear speed of the sling in inches per second? Okay, so now I need to find linear speed. This question is kind enough to tell me what kind of speed I'm converting it into. I have two options of how to proceed. I can work from the original 75 revolutions per minute, that rotational speed, or I can convert from my previous answer, the 2.5 pi radians per second, that angular speed. Okay, well, I'm going to go from the original problem because 75 revolutions per minute seems like a much neater answer. There's no decimals, there's no pi's, so I'm going to go from that. So to get from rotational speed to linear speed, I'm going to need this conversion factor between linear speed and rotational speed. So I need to know the actual measurement for the circumference. So one rotation over the measurement of the circumference, or I can change words, one revolution over the measurement of the circumference. So the circumference, 2 times pi times the radius. I need to use this radius. It says the sling is 26 inches long, so I calculated the circumference, 2 times pi times 26, or 52 pi inches. It's approximately 163.36 inches in this case. So that's going to be part of my conversion factor. So I'm going to take the 75 revolutions per minute. I'm going to multiply it by this conversion factor, 163.36 inches per revolution. Every time that sling makes one complete circle, it has traveled 163.36 inches. So far, these green revolutions and these red revolutions cancel each other, and I'm left with inches on the top and minutes on the bottom. That's not what I want. I'm supposed to get seconds. And so I'm going to have to add one more conversion factor. It's the same one that I used last time, so 1 minute is 60 seconds. If I had chosen to work from my previous answer of the angular velocity from part 1, I would not need this conversion factor again. In hindsight, that actually would have been faster. Okay, so I've got my calculations set up. I'm going to drop that into the calculator, 75 times 163.36, and then divide by 60. I've typed that in here, and end up with 204.2. So if I had worked from either my previous answer, that would have been easier. If I had taken the 2.5 pi, that already was in radians per second. So in that case, I would not have needed this blue minutes to seconds conversion factor. Alternatively, in the calculation that I just did, if I had used 52 pi rather than the 163.36, I would have gotten a more accurate answer, because with the 163.36, I've already rounded that. If I leave it as 52 pi, I'm going to get a more accurate answer. I think either way, we're going to be fine in this problem, but in general, the longer you leave pi as part of your answer, the better. So I'm going to back up. Here's option number 2 for the second question, to find the linear speed of the sling in inches per second. If I work from my previous answer of 2.5 pi radians per second, which is an angular speed, and I need to convert to a linear speed, my conversion factor between angular and linear is the actual number that is the length of the radius and the word radius. So my problem gives me a radius of 26 inches. The length of the sling is the radius. So I'm going to put 26 inches over 1 radius. Purple rad, red rad are going to cancel. And now just multiply straight across the top. So it's going to be a lot shorter than what I did last time. All right, let's drop this calculation into the calculators. I got 2.5 pi times 26 all queued up. It equals, so there it is, same thing I got last time, 204.2 inches per second. Okay, so this took only the one conversion factor, whereas last time I had to have 3, well, the starting value and 2 conversion factors.